experiment is going to be on calibration of single phase watt-hour meter. These are the objectives of this experiment. Objective 1, understand the working principle of watt-hour meter. 2, master the wiring method of watt-hour meter. And 3, study the calibration method of watt-hour meter. So these are the objectives of this experiment. So let's see the equipment for this experiment. So we have control panel, incandescent lamp, 3-phase switch, analog meter 1, analog meter 3, watt-hour meter 2, and connection wires. So these are the experimental equipment, or the models that we are going to use to perform the experiment. So now let's see the working principle of watt-hour meter. So watt-hour meter is a kind of induction meter, the main components of which are a voltage coil, a current coil, aluminum plate, brake magnets, and mechanical counters. So then the interaction between the current flowing through the voltage coil and the current in the current coil leads to an alternating magnetic flux, which induces the eddy current. The alternating magnetic flux and the eddy current act with each other to produce a torque, which makes the aluminum plate rotate. So now the permanent magnet above the aluminum plate can generate a braking torque to make sure the aluminum plate of uniform rotation and its speed is proportional to the energy consumption on the load. So now the permanent magnet above the aluminum plate can generate a braking torque to make sure the aluminum plate of a uniform rotation and its speed is proportional to the energy consumption on the load. The mechanical counter driven by the aluminum plate records down rotation number within a certain time, and with the continuously increase of power to accumulate, it reflects the accumulation of total energy value. So now let's see the calculation or the formula of meter constant. N stands for the aluminum plate rotation number in a certain time, and W is power consumption of load. So N is proportional to the W, that is C, which is equal to N over W. The proportionality coefficient C is called meter constant. So the C is called meter constant, which is often marked in the meter. The unit is R per kilowatt hour, which indicates that how many times the aluminum plate rotates when 1 kilowatt electricity is consumed in 1 hour. So you should take note of that. So meter constant indicates that how many times the aluminum plate rotates when 1 kilowatt electricity is consumed in 1 hour. The circuit symbol of watt-hour meter and wiring diagram. So let's see the circuit symbol of watt-hour meter and wiring diagram of the experiment. The connection method is the same to the power meter, and the input of current coil and voltage coil are connected inside. So the input of the current coil and the voltage coils are connected inside of what? Of the watt ammeter. So now there are 4 terminals outside. End points 1 and 2 respectively are connected to power size life wire. End point 1 and 3 respectively are connected to power size life wire and zero line. While end 2 and 4 to low side life wire. While end 2 and 4 to load size life wire and zero line. In the experiment, the single phase meter rated parameters are 380 volts per 10 amps, and the meter's constant is 600 R per kilowatt hour, and with the accuracy rating of 0.5. So let's see the wiring diagram of the experiment. So we have for L, which is the live, and the N, which is the neutral. So you see the live wire is passing through the ammeter. So as I said, ammeter is always what in series with the circuit. So it's passing through, then it's passing the input it here and what you output it here. So the output of the ammeter goes to the endpoint 1. Then from the endpoint 1, you exit the live output from the endpoint 2. So now the endpoint 2, which is the output of the live of the watt ammeter, goes to the live input of the voltmeter. So from the voltmeter, you will tap it from the, look at the junction here, you will tap it from here, then you insert to the switch the input of the switch, which is connected to the load. Then from there you tap it to the next load, that the second load. Then you tap it to the next load, which is the third one, with the third load. So now since it's a single phase, so we join the live together to supply to the loads. Okay, so we have done with the live connection. So we go to neutral. So when you see this, so from the neutral connection here, so from the look at this, so the neutral here, which goes straight to the neutral input of the voltmeter, and you tap it for the neutral input of the voltmeter to the endpoint 3 of the energy meter, which is the watt ammeter. Then the endpoint 4 is the neutral output of the watt ammeter, which goes to the load. So we set to the load, then you tap it as we did to the live. So the endpoint 4, which is the output of the watt ammeter, goes to the neutral input of the load. So this is the explanation of the wiring diagram. So let's move to the experiment itself. Okay, so before we start our experiment, we need to introduce the model that we are going to use to perform the experiment. So first of all, we need to identify. So we say, because we are going to use the control panel, then the analog meter 3, we have the watt hour meter 2, we have the incandescent lamp, 3 incandescent lamp that we are going to use it as well as our load. Okay, so before we start the connection here, so we need to introduce the model that we are going to use to perform the experiment. So first, we are going to use the control panel where we get our voltage sources from. Then we are going to use our analog meter 3. Then go to watt hour meter to the 3 incandescent lamps, which is here. So to start our connection, so first we start from the live wire. So since I'm using the red cable, I prefer using the red phase. So I will take it from here, insert it to the phase. Then from the circuit, we see goes toward the ammeter. So this is the ammeter here. So I will send you the input of the ammeter. Then I'll pick it from the output for ammeter, which goes to the number 1, because the watt ammeter is numbered 1, 2, 3, 4. So the 1 is the live input and the 2 is the live output, and 3 is the neutral input and the 4 is the neutral output. So this one will go here to the number 1, which is the input, live input. Then I'll pick it from what? Number 2, which is the live output, which goes to the voltmeter. I will insert it to the voltmeter. Then from the voltmeter, I will tap it. For the voltmeter, I will tap it to the what? To the load. So I pick it from here. Then I will step it to this side. Then since we are using 3 incandescent, since we are using a single phase, then we have 3 lamps there. So we need to what? Loop it, or we need to what? Tap it to each other so that the power can pass through across all. So we tap it from here to this side. I'll tap it from here to this side. Okay, so now I'm done with the live connection. So let's go to the neutral connection. So I'll pick the back cable, so the neutral here. From the circuit goes to what? To the voltmeter. So to the voltmeter. Then I'll tap it from the voltmeter to the watt hour meter. So to the watt hour meter, the input of the watt hour meter. Then I'll take it from the number 4, which is the output of the watt hour meter, to the load. Send to the load here. So since this is what I need to what? I need to loop it. So I need to what? Loop it. I'll loop it. I'll loop from here. Okay, now we are done. I'm done with the neutral. So now I'm done with the neutral. So now we need to check the continuity before what? We power it. So I'll put one here at the red. So since I put at the red, all the red cable that's going to beep. The black won't beep. So check. Beeping. The black will not beep. It means, so now since it doesn't beep, so it means that the live wire doesn't have connection with the neutral, so we can continue or proceed to power it. So we on our breaker, then since there's no load, the ammeter is reading 0.0. It's at 0. Then you see the voltmeter is reading the incoming voltage, say 203. So the voltmeter is reading what? 203. Then when you look at the energy meter, it's what? It's not reading at all because there's no load applied to it. So it was not moving at all. Okay, so now introduce one load. So we see it here. Since we have introduced the load, you see that the ammeter has run from 0 to 0.2. Then the energy meter is reading slowly. It's also reading. You see that it was reading slowly. It's reading. You see, the disc is moving slowly. Okay, so now let's apply another load to it. So since we introduce another load, we see that let me see. So now since we introduce the two loads, it will move from 0.2 to 0.3, but the voltage is at the same position. When you look at the energy meter, it will start moving. Now see the energy meter, it will start moving faster than the initial. We are using only one lamp. You see, it's moving. Let's introduce all the loads. So we are going to add the third one to it. So when I've added the third one, you see that the ammeter, the ammeter has moved from what? 0.3 to 0.6. But the voltmeter is at 8 station, which is what? 202. Then let's see the energy meter. So you see, the energy meter is what? Moving faster than the initial when we are using what? Only 2 lamps. So you see, it's moving faster. The energy meter is what? It's going faster. You know that the energy meter is what? Moving faster. Because more energy, what the two loads are consuming more than the initial. So you see, the meter is what? Moving faster. It's moving faster than the initial when we are using what? 2 lamps. So as more load applied, as more energy, that's what you are consuming. Okay, so in conclusion, so we say that as more load you applied, and more energy that you consume. So the energy meter will move faster to read your consumption. In conclusion, by this experiment, you should have understand the working principles of watt hour meter, grasp the wiring method, learn to measure the load's electricity energy consumption, and study energy meters calibration method. So watt hour meter is a kind of inductive meters, and its speed is proportional to the load's energy consumption. The mechanical counter driven by the aluminum plate records down rotation number within a certain time and with continuous increase of power to accumulate. It reflects the accumulation of total energy load. The mechanical counter driven by the aluminum plate records down rotation number within a certain time and with the continuous increase of power to accumulate. It reflects the accumulation of total energy value. So this is the conclusion of experiment.